Out on the Arctic pack ice, winter temperatures regularly plummet to 50 degrees below zero. At those extremes, exposure is lethal, and finding shelter is the only way to survive. Yet the Inuit have managed to live in this forbidding environment for about 5,000 years. They accomplished this in an area completely devoid of forests. Nomadic hunters had to build with the only raw material at their disposal: snow. Using frozen water to build a cozy, life-saving shelter is a difficult concept to grasp. It seems illogical to seek warmth from a material that is, by definition, freezing. Intrigued? To understand how this works, we need to take one of these structures apart and look at the specific physics that allows it to hold on to heat. We first have to redefine what it means to be cold. Cold isn't an invading force moving into your body. Instead, when your body temperature drops, you are actually feeling your own heat energy leave you. This diagram shows the 3 ways a human body gives away that heat. It escapes via convection, which is the transfer of heat through moving air; conduction, the transfer of heat through direct physical contact with the ground; and radiation, the emission of heat energy as outward electromagnetic waves. Biology offers a solution to stopping this rapid heat transfer. Sea otters survive freezing water because their spiky fur is dense enough to trap microscopic pockets of air directly against their skin. Fresh snowflakes perform the same trick. Their crystalline structure traps enormous amounts of air, creating a matrix that is up to 95% empty space. But fresh powder isn't dense enough to build walls, and solid ice is far too heavy to lift. Inuit hunters cut blocks of tightly packed snow straight out of the ground, finding a balance between structural stability and high air content. This material allows the igloo to rely on the massive volume of trapped, insulating air held within the snow block's physical structure, rather than the ice itself. While cartoon igloos are usually drawn as simple, flat-bottomed half-spheres, that shape is much less stable than the one actually used on the pack ice. Properly built igloos utilize a catenary arch. This is the gradually sloping curve that naturally forms if you hold a chain by both ends and let it droop. Because of this specific slope, the weight of the snow blocks travels smoothly down the curving walls straight into the ground. This prevents the structure from bulging or buckling under its own mass. The floor is also carved into distinct vertical tiers, featuring a raised sleeping platform and a sunken entrance trench at the bottom. This layout manipulates fluid dynamics. Because hot air expands and becomes less dense, the warm air naturally rises to the elevated sleeping platforms. The freezing, heavy air sinks and pools in the lowest exit trenches, keeping the living space warm. Over time, the occupants' radiant body heat slightly melts the innermost layer of the snow walls. That water quickly refreezes into a solid ice seal, creating a windproof barrier between the inside air and the porous snow blocks. This architectural shape and internal layout work together to manage gravity and airflow, creating a stable thermal environment. The igloo does not generate any heat of its own. It relies entirely on the human body acting as a living furnace to power the system. As you sit inside and radiate thermal energy, the internal temperature can stabilize 40 to 60 degrees higher than the deadly Arctic air outside. This thermal visualization demonstrates how that effect scales up. Adding more people to the enclosed space increases total heat generation, warming the shelter significantly faster. For thousands of years, the Inuit have used pure intellect to solve a brutal environmental problem. They looked at nature's harshest element, recognized its physical properties, and turned it into survival technology. If you've made it this far, thanks for watching. Please consider subscribing to Deep Dive Daily, hitting that like button, and dropping a comment below.